All right, so expressions and equations. These are pretty tough. Notice you don't have a calculator. Some of these you should be able just to look into your head and do. So we talked about the distributive property. Yay? Notice again, the distributive property only works when there's a plus sign in the middle. So all of this 1/2 x will go into each thing separated by a plus sign. So for example, let's be purple. Okay, so the x squared is gone, but all of this whole thing needs to be distributed to everything inside. So what do we got? What do we got? X squared, thanks. Go, Jasmine. XY. X squared, awesome sauce. Okay, now, here we go. Combine like terms. What's x squared plus 1/2 x squared? 1.5 x squared, which we don't like using mixed numbers, so can you give me an improper fraction? What's 1.5 x squared is an improper fraction? 3/2, thanks. 3/2 x squared plus 1/2 xy. And that's a fair enough answer. Notice all the like terms are combined. Usually we put the x's in front, anything mixed in the middle, and then the y, if there were any y terms, would be at the end. And notice also that the highest degree is in the front. Yay? Okay. All right. What about this one? Hello? Just say it. Talk to me. 3, because the 5 cancel out, right? Yeah. Okay. Plus b. Very nice. And then we have the 3/5 and the 1b to go together. Does anyone know what that is? Negative 3/5 plus 1. Yes, this is definitely a 5/5. So let me write this in a different color. There it is. All right, so there's a 1 here, so you can also think about this as 5/5. So when you're combining, it's negative 3/5 plus 5/5, which is, yeah, so it's 2/5 b plus trig. Yay. It's good. Okay. All right. Evaluate. When it says evaluate, you actually have to come up with a number if there's a number to plug in. Okay. So, for example, in this one it says x is -2. So if you're plugging in the x in here, first it'd be helpful to combine like terms. Simplifying this thing, you would get squared plus x minus 1. Okay, so first thing, just simplify, right? And then just plug in for x. So watch out. When x is a negative number, always put parentheses around it, because if you do -2 squared, that's different than parentheses, -2 close parentheses squared, right? So especially when there's a negative, make sure you put parentheses around those values. Plus -2, then -1. So all I did was substitute. -2 squared yields 4. Plus -2 is just -2, and then -1. So 1! All of that work to get 1. Joy. Yay? Yay. Okay. Here we go. Am I going too fast? Excellent. Moving on to number 4. All right, case 7. So if it's a positive number, just plug it in. No need to worry about signs. So 2 times 7 squared plus 3 minus 2 over 7 minus 5. Okay. You can work on the top and bottom individually. You can do the steps individually, and then combine at the same time. For example, over here, the 7 squared in the order of operations is exponents. Well, you're working on parentheses, but inside parentheses, you have an exponent. So I do the 7 squared first. So that would be 2 times 49 plus 3 minus 2. And the bottom is just 7 minus 5. So that's just 2. Yay. Okay. Moving forward, the 49 plus 3. Tails, PFD, 2 plus 2, all over 2. Yes. Next, 104 plus 2 over 2 is next. And then 10. That is minus 2. Sorry. That is a minus 2. Thank you. I totally messed up that sign. Okay. Okay, sorry. It's a minus 2. Yes. Okay, back to the 10. Okay, so minus 2, minus 2. So that'd be 102 minus 2 over 2. No, 102 over 2, not 102 minus 2. Sorry. There we go. Better answer. There you go. Whew, that was painful. There you go. 51. Finally. Joy. Okay. As far as work goes, for the evaluate, if you could just show me what you plugged in, right? And I mean, if you want to skip a few steps over here, that's fine. As long as I can see exactly what you plugged in, that should be enough. Should show enough work for me anyway. So if you want to go from here to, let's say, here, because you already evaluated what was in here, that's fine. Yeah. Okay. What should we do? Yeah. So either subtract 3 or subtract 6 or multiply everything by 3. If I get all the x's on one side and all the regular numbers on the other side, then multiplying by 3 won't be as confusing. So let's try subtraction first because it's the easier operation. It's going to give you the same thing, definitely, Abby. But if you separate it from variables to expression or to constants, then it won't be so. You won't miss any parts, basically. So you have 2/3 x equals 4, right? And then Miss Abby says multiply by 3. Yeah, so we're going to multiply everything in here by 3. This becomes 2x equals 12 and x equals 6, right? You may always, always, always check your work by plugging it in. Alright, I don't understand how folks just let math tests go without checking the work. You can always get an A if you just plug in your stuff just to make sure it works out. And if it doesn't, keep working on it. Right? If you plugged in 6 over here, 2 times 2 is 4 plus 6 is 10. So, yeah. Alrighty. Now what? Multiply by -4. So multiply the -4 to the 15 side. So you got 6y plus 30 equals 60. Then 6y equals 90. Y equals negative. Is it 15? 15 or negative 15? It's negative 15, right? Yeah. Okay. All right. Let's get to some tricky ones. All right. So here's what I mean, Miss Abby. I wanted to thank you for bringing that one up. I wanted to show you this one. Okay. So let's say you just want to multiply everything by 3 first. You could go the other way and simplify it first. Well, let's say we multiply everything by 3 to get rid of the fractions. The trick is, right, to make sure that you multiply, yeah. If you multiply by 3, be careful because multiplying 3 to this doesn't mean multiply 3 to the 2/3, the 6, and the c, right? That would be the biggest mistake is to distribute everything into here. You would distribute it to here and here, but you'd only distribute it to the 2/3 because the operation between it is multiplication, whereas the other one is subtraction. So the mistake again I would see is distributing it too far. Thank you. Yes. So this is a mistake. This is over distributing. right? Because over here, you don't need to distribute the 3 to everything else. You just need to distribute to 2/3. Or the simplest thing would just be distributed 2/3 in the first place. So if you distribute it first, you have the chance to over distribute. So what I would suggest is to simplify first. Okay, so on this side, the 1/3 C minus 8 is already simplified. But the negative 2/3 can be distributed to the 6 and the C. Yay? Negative 2/3 times 6 is negative 4. Nice. Plus 2/3 C. Is good? Is good. Okay. Let's move the C's to one side and the numbers to the other side. So I'm thinking move this thing to the other side by subtraction, right? So we're going to get negative 8 equals negative 4. 2/3 minus 1/3 is 1/3. C. Yeah. Add the 4. Negative 4 equals 1/3 C. C is negative 12 equals C. So you can see here by simplifying first, you can avoid all this mess. Yay? Okay. All right. Next. What? We'll get there. What would you like to do? Distribute the negative 3 right here. Okay. Let's do it. Okay. So on this side, we're going to get negative 6z plus 9. Okay. On the other side, how about this? Can we distribute the, well, actually, let's just leave it as negative 27 plus 6z, plus 1 over 3. Okay. Now for it. Multiply by 3, exactly. So if we multiply everything by 3, right? So here's the distribution. So we're going to multiply the negative 27 by 3, which is, I'll do it for you. There you go. When you multiply this thing by 3, all it does is cancel the denominator. So you're going to get 6z plus 1, right? And then negative 3 times negative 6, negative 18z, and then 3 times 9 is 27. Joy! Now what? Let's combine. I'm going to move the 18z to the other side, and then combine the 81 into 1. Well, let's do that. So let's do negative 80 plus 6z equals negative 18 plus 27. So that way it doesn't look like it's too much going on. Move the 18 to the other side, you get truth, right? Move the 80 to the other side, you get hello? Yay! So z is equal to don't give me decimal. Don't give me decimal. Improper fractions from now on, right? Improper fractions are all you need for like calculus and stuff. You don't have to. Grab a pen. Yeah, grab a pen from my desk real quick. All right. Teddy, can you wait for like 2 more problems? Good? Okay. All right. Did anyone try numbers 9 and 10? Why? Exactly. In 9, you get 2 different answers on this. It's either 2 things that don't equal. So if you haven't worked on it yet, here we go. All I did was distribute the 3 on that side. Okay? Equals negative 3x plus, yeah, plus 5. So check out what happens. This is 3x plus 4, and this is 3x plus 5. We can cancel out the 3x on both sides. This 4 equals 5. Heavens no. So, IB kids, I'm going to see you guys in HL or SL as juniors. This is called an inconsistent. Right? This is called an inconsistent equation. So therefore, there is no solution. Yeah, for some reason they got me teaching junior SL this year. So I may or may not see you next year. Yeah. All right. What happened over here, Miss Jenny? You haven't solved it yet? Woo! This one's a doozy. Come on. Here we go. All right, let's distribute. Here and here. You do that. Hello? Plus 4. No, I got you. There you go. Oh, good old inverse property. 2/3 times 3/2 is 1. So it's 1. And over here, the 3 cancels the 3, and the 2 goes into 4 twice. So this is minus 2x. Again. There we go. 1 plus 4x plus 4. Joy. Okay. 6 minus 2x, that's 4x. Yay. Plus 5 equals 4x plus 5. It's infinite, yes. It's infinite many solutions. In our case, the solutions is all real numbers. Right? That's the one where the line is on top of itself. Yay? So, the lesson of the day. If you get a true statement where both sides are equal, then it's all real numbers. If you get a false statement, it's no solution. And they all lived happily ever after. The end. Is it good? Okay. Here we go. Ooh, I needed to save that, didn't I? So,